our outer function is now. Yeah, this is my outer. And then we've got an inner function here. And so, Marek, we know the derivative of sine. If you look back here, you're like, dude, I thought the derivative of sine is always cosine. I agree, when that angle was just x. Now, do you guys agree this angle is a little bit more complicated? So, that chain rule. We ate those M&Ms very strangely yesterday. We ate the outer shell first. Take that derivative of sine. What would be the derivative of sine? It is still cosine. But then you can only do one derivative at a time. So since I took the derivative of sine, I need the angle to stay. So I'm going to say, oops, the derivative of sine, my bad, is cosine. Come on. So that angle has to stay. Then, lastly, we've got to multiply by the derivative of the angle. What's the derivative of 3x plus 1? 3. Now, you're like, what the heck? Why didn't we have to deal with this earlier? Well, you guys, when I said, what's the derivative of sine of x? And y'all said, oh, I know the derivative of sine of x is cosine of x. Technically, we are still doing chain rule. What's the derivative of this angle? Derivative of x is just 1. So is that really what we've always been doing? We just haven't had to worry about that angle because the derivative of the angle was always 1 and it didn't mess with it. When the derivative of the inner is not 1, we just got to make sure that we keep the derivative of the inner going on. Okay? All right. Let's try. This is a little AP from 2016. Here we go. Do we have an outer and an inner here? Yeah, we've got an outer and an inner. So first take the derivative of that outer. You guys, and you can act like, what if it was just x to the 5th? What would that derivative get me? 5x to the 4th. Look what you did with that inner. You just left it. 5x to the 4th. So I'm going to leave it. I'm going to say 5, leave it to the 4th. I left my blue inner. I took the derivative of the outer. We just did the derivative of the outer. We left the inner. We're like here. But now do we have to take the derivative of that inner? Yeah. What rule do we have to do for the derivative of this inner? Was that you, Ritz? He said the quotient rule. Don't we? Because we got division in there? Yes. So we need to multiply this by the derivative of the inner. And the inner being quotient rule. We start with me. Low, D, high. What's the low here? Whoops. X plus 1. Thanks, bud. D high. 1. Yep. Low, D, high minus high. D low, the derivative of the lower, you're right, is just 1. All over low, low. Whoa, I was just doing the quotient rule with what's just in blue. And then you're like, well, that doesn't look like an answer. That is unfortunate. Let's see if we can simplify some stuff. I want to just simplify. I'm going to focus on this over here and just simplify this yellow. What's this going to get when I multiply x plus 1 times 1? X plus 1 minus an x. Isn't that just going to get me a 1 up there?
Yep.
Okay, so I'm going to leave this other stuff. I had a 5. I had an x over x plus 1 to the 4th. And then on top, you just sort of have a 1 over x plus 1 squared. I didn't do anything to that. Low. Good. And that still doesn't look like an answer, but I think we're getting closer. If we put all of these as fractions, instead of 5, this could really be rewritten as 5 over 1. Yeah, and you're saying, oh, well, this to the 4th goes to the top and to the bottom. So this is really a 5x to the 4th on the top. Is that looking like any of these? Okay, C, D, or E potentially. 5, C, D, or E, because I got a 5x to the 4th. And then what do we have on the bottom? And I'm going to just remind you, we could rewrite this as x to the 4th. Like we could take that, whoops. This is really x to the 4th over an x plus 1 to the 4th. That 4th has to go to the top and the bottom. So this is just me. Is this looking like an answer? To go from this black step to this red step, I just really separated this x to this 4th. I took x to the 4th over x plus 1 to the 4th. Boom, boom. Is that looking like an answer? Yeah. What is it? Is it going to be 4 x plus 1 to the 8th or to the 6th, do you think?
6th.
Yeah, you add those exponents. Final answer, A, B, C, D, or E? D. Boop. Okay. Let's take this a little farther. We got an angle, an outer, and an inner. And then they're asking, okay, not only what's that derivative, but also what's that derivative when x is pi over 9? Gross. People, we can do this. What's the derivative of the outer? Derivative of cosine. Yes. Leave the angle. Times the derivative of the angle. What's the derivative of that 3x going to get me? You got this, people. Derivative of 3x? You got it. Okay, could I just rewrite that as -3 sine of 3x? Just put that constant out front. That's all I am doing right there. Boop. Just putting it with the negative. You just found the derivative. Let me say that one more time how we did that. We took the derivative of the outer. We left the inner times the derivative of the inner. It's like we ate the candy shell of the M&M. We left the chocolate. Then we ate the chocolate. Okay, people. Now we got to go plug in a pi over 9 right there. So I'm going to say, all right, f prime of pi over 9 is going to get me -3 sine of 3 times pi over 9.
Which gives a pi over 3.
Right, because, correct me if I'm wrong, Coop, pi over 9 is not on our unit circle. No, but they did that on purpose. 3 pi over 9ths, 3 pi 9ths would get me a pi over 3. So we've got -3 sine of pi over 3. What is the sine at pi over 3?
It is √3 2.
The sine at pi over 3 is, yes, √3 over 2. Final answer. What's my final answer going to be? Is that E? Ooh! Product rule, quotient rule, or chain rule?
Chain.
It's a chain because this is not f of x times g of x, even though it kind of looks like it. This is a chain rule, so maybe you remind yourself that's my outer, and then this is my inner, because it's not being multiplied. It's quote-unquote of. Okay, let's do that derivative. Derivative of the outer, eat that candy shell would turn into f prime. Leave the chocolate would keep it as g of x. And then eat the chocolate. G prime, you got it, girl. And they said, hey, find that derivative when x is 2. You know me, I'm a big step shower. I really like to leave it there, and then I'm going to throw my 2 in there. So I'm going to say f prime of g of 2 times g prime of 2. What do we have to find first? Yes, g of 2. Is that in my table?
Yes, it's 2.
It is 2. What a coinky dink. So how I bring that down is I say f prime now of 2. This 2 came from g of 2. I wish that was a little different number. Then I need to multiply f prime of 2 times g prime of 2. What do we think g prime of 2 is from our table? You got it. This is not f prime of a number. We got to first, we're using this value here. We're looking now for f prime of 2. F prime of 2 is, yeah, f prime of 2 is going to be a third. So I'm going to get 1/3 times -3. Final answer, -1. Good job. Good job. Good job. Okay, this is what Coop's asking. This is specifically why I put this on the notes, because I think this is so hard. You guys, when I say the derivative of tangent, if I say the derivative of tangent is secant squared, isn't that technically secant of x squared, like that, Coop?
Yeah.
This is just how books and the EP like to write it. These are the same thing, though. So what is this? Yes. So what is this thing right now? Do not even change, you guys. Let's just rewrite it because there's so much going on. The derivative of, this is technically sine of x squared. And then that quantity is cubed. So you guys, this is now the outerest. We now have basically an everlasting gobstopper with all those different layers. You know what I'm saying? You guys ever eat an everlasting gobstopper and all the colors change? Love. He's like, my God, this goes on forever. Here we go. The derivative of the outermost, the derivative of my something to the third would become 3 something to the second, right? What do we do with that inner? You always leave it. So we've got sine of x squared is in the middle. And we just took the derivative of the outer. That is one derivative. We left everything else. Guess what we got to do next? He's like, oh my God, we literally are peeling back layers. Yes, that was my outer. This was my inner. So now if we're taking the derivative of this is now my outer and this is my inner, right? So what's the derivative of sine? Cosine, leave the angle. So we have cosine of x squared. I've got to leave that angle because I can only do one derivative at a time. The derivative of sine is cosine. Left the angle. This is why Cooper's laughing. We still need to multiply it by the derivative of the innerest. The derivative of that x squared. Done.
Oh, so you don't have to go back out.
That's a good call. We are literally just peeling that onion from the outside in. So we took the derivative of my 3. We left the inner. We took the derivative of my sine. We left its inner. And then we finally took the derivative of that angle. Very good. Holy smokes. Is this an answer?
Yeah.
We got 3 times a 2x. Is that the 6x here?
Yep.
And then is this equivalent? Coop, is this with that 2 on the outside equivalent to this?
Yep.
Yes, sir. And then we also had cosine of x squared. Whoa. How could I rewrite this thing to help me with my layers? My original function is really the cosine of 3x, exactly, that quantity squared. I think rewriting this is huge so that I can see what is my outerest layer. What's the derivative of something squared going to do? I'm sorry, let me rephrase that. Let's take the derivative of my outer first. That would become 2 something to the first. We leave that something in there. Exactly. So you took one derivative, and now it's the derivative of the outside. Perfect. That's all we can do in one step. We left the inner. Now what is the next derivative we're going to take? Derivative of cosine is negative sine. If I write it like this, is that correct? No, because that would be minus sine, right? And we got to multiply all of these layers. Well done, Tatum. And I did the derivative of cosine is negative sine. I left its angle because I can only do one derivative at a time. What do we finally need to multiply all of this by?
3.
Yeah, the derivative of that angle, which is 3. Does that match up to be an answer?
Yeah.
Oh, 2 times a negative 1 times a 3. And you might be like, what? That is a negative 1? It sure is. This is really a negative 1. So we've got a coefficient now of negative 6, cosine of 3x, and then a sine of 3x. You thinking A? Me too. Here we go. 2016. So here we go. They said, hey, K is f of G. And they want the equation of the tangent line. You guys, one more time. We're going to be doing this the whole year. This is just that point slope form. That point slope form. In order to do point slope form, we need a point and a slope. Which one would you guys rather find first? I don't care. Slope. Okay. We need slope when x is 3. If K is f of G, which rule should we use? Product rule, quotient rule, or chain rule? Chain rule. So if I need K prime of 3, it's going to be chain rule. Derivative of the outer would just turn into f prime. Leave the inner. I'm going to just throw my 3 in there. It'd be the inner is just g of 3. And then what do we need to multiply that by? The derivative of that inner, g prime of 3. And I'm like, okay, I got a table, and they give us excessive amount of values. What do we need first?
G of 3.
You got it. Very good. We need g of 3. What do we got for g of 3? 6. Cool. So what I'm going to write is I'm going to say, all right, then I need f prime of 6. And we also need to multiply that by g prime of 3. We could go get that now if we wanted. What's g prime of 3?
2.
G prime of 3 is 2. Mark, I haven't seen him since August, and he's on it. He is on it. I'm just being ridiculous, Mark. G prime of 3 is 2. You guys, then we just take f prime of 6 times that 2. F prime of 6 is 5,
10.
which is 10. So you're saying f prime of 6 was 5 times that 2 gets me 10. My slope is 10.
And since we know G of 3 is already 6.
That's so good. He says, all right, we've got a slope. We still need to go get my point. You guys, my point for k when x is 3, correct me if I'm wrong, I just got to go plug a 3 in for x right there. So to get my point, I need k of 3, not k prime. A point is just plugging in x into my function. If x is 3, this would be f of g of 3. F of g of 3. And you're saying we already knew what g of 3 was, or we could look back in our table. G of 3 was 6. So k of 3 would be f of 6. F of 6, is that a thing? Yeah, f of 6 is 4. So now we have a point and we have a slope.
What does that look like on the graph?
Y minus, yeah, equals my slope of 10. Boom. On this one, what do they want? They want the derivative, right? Holy smokes, we need the product rule because we've got f of x being multiplied by this root. Yes, so we do need the product rule. Pause. Ritz, what you have? Product rule, what would f prime be here?
5.
5, I agree. So I'm going to say dy dx equals 5. That's f prime. What's my g going to be? Agreed. Perfect. This right here is f prime g. Life is good. Plus, now g prime is where we have a problem.
5x times x squared plus 1 to the negative 1 half.
Close. Not negative, right? Because it's just to an exponent. Wouldn't need to be negative, right? Wouldn't this just be 5x times x squared plus 1 to the positive half? Because if it was negative, it would have to be in the denominator.
Well, you have to have g.
For g prime, here's g. Here's g. I haven't done anything to g. To go find g prime, what do I have? Do I have an outer and an inner?
Yes.
Holy smokes.
We're
So
going to have to do the chain rule.
within product rule, we now have to do the chain rule. Whew, Cooper, for that conniption, Mr. Fumbles with the phone. Here we go. Coop, help me with the derivative of the outer. What would the derivative of this outer be if it was to the 1/2?
The derivative of that would be 1/2 x squared plus 1 to the negative 1/2.
Yes, sir. Now, Coop, correct me if I'm wrong. You just took the derivative of the outer and you left the inner, yeah?
Yes.
That is the start of chain rule. What do we need to multiply that by to finish the chain rule?
2x.
Agreed, which is, how'd you get that?
Because x squared plus 1 would be, that would be the derivative.
Exactly. So let me say that one more time. Coop took the derivative of this red, the derivative of the outer, we left the inner, times the derivative of the inner. Whoa, this right here is all g prime. Holy smokes. Multiply this by f. Biscuit, what's f?
Right at 5x.
5x, you got it, dude. This is times f, which was just 5x. Oh my gosh, and who wants to murder this question? Because look at these answers. And this is where we are. We're going to get there, okay? We're going to get there. We are a team. Oh, they did say when x is 3. That's going to help us a lot. I say let's throw in a 3. Let's throw in a 3. Who wants to do that? We still got the candy jar out. Oh, wait. G. Throwing in a 3. I feel like, Tatum, this has been your unit, girl. You've got this. You ready? Let's throw in a 3. You got this. TT, ready? We got our 5. What's throwing in a 3 for this x going to get me?
9.
Agreed, plus 1. And then T, I'm like, okay, I'm seeing some root 10s that like eases my worry a smidge, okay? Let's keep going, T, and don't worry about the negative exponent yet. What's this going to get me in here if x is 3?
10 again.
Agreed. So I'm going to just say 1/2 10 to the negative 1/2. That looks gross. Keep going, T. What is 2 times 3? Times?
15.
Perfect. She said 5 times 3 is a 15. Holy smokes, people. What What's the one thing that's scaring us right now? Right. So let's get rid of it. Something to the 1/2 is just a square root, right? So could I just bring this thing down? So I'm going to leave this 5 root 10. I'm going to leave it. So we got a 5 root 10. Then actually, could we multiply my 1/2 times my 6 times my 15? Could we just multiply all my coefficients? All right. What is 1/2 of 6?
3.
3 times 15. 45. So then I have plus 45. And then are we cool if we put 1/10 to the 1/2? And that's just me saying, get out of here. Get out of here. So we're good with, I brought this guy, which is 10 to the negative 1/2. I just brought it down as 10 to the positive 1/2. What's the same as something to the half?
Square root.
Square root. Okay, guys, we're getting there. I promise we're getting there. We got 5 root 10
We are there.
plus 45 over root 10.
Yes.
Oh, is that an answer?
Yeah, that's D.
I got D. Whoa. Now, on the AP test, non-calculator active questions, you get on average 2 minutes per question. Did that take us more than 2 minutes? Yeah. Are some of them going to be less than 2 minutes and some going to be greater? This one was a long one. Whoa. Beck, product rule, quotient rule, chain rule, all of the above. What are you thinking? We got to start with the product. I love that, Beck. He's like, all right, I see one function times another function. Let's go find the derivative. So he says, let's start with product. Agreed, Beck. Beck, F prime. What would you say F prime is?
1.
Agreed. Times G. What was my G?
X squared plus 2 cubed.
Beautiful. He's saying that's already fig. We're halfway there, you guys. We're halfway there. We need help with the G prime. And on this, do you agree I have an outer and an inner? Gross. We can do it, though. We can do it. What's the derivative of that outer going to get me?
I already got it. It is.
Hold on one sec. Hold on. Not everyone's gotten candy, so I'm going to try to spread the wealth. Anyone want to do the derivative of the outer that hasn't gotten candy? Dean, go for it.
3 parentheses x squared plus 2 squared.
Times. So good. Listen to what you just did. You said the derivative of the outer. You just changed the exponents. And you left your red inner. Then you're like, shoot, I still got to take the derivative of that inner. And the derivative of that inner one more time, Deanie, was a 2x. That whole thing is G prime. Whoa. Fig plus GIF. We got to end with the F. What's the F there, Mr. Dean?
X minus 1.
Very good, buddy. This does not look like an answer. We are right, but this is not an answer yet, right? Ms. Here we go. Let's just simplify this right side, shall we?
Yes.
Let's just simplify the right side because this left side just looks like it's x squared plus 2 cubed. I haven't done anything to this side other than get rid of my 1. Let's just simplify this side. What would I have out front? What would be my coefficient?
6x.
Yeah, right? So couldn't we simplify 3 times 2x to get me 6x? So I'm going to say plus 6x. Then I have an x squared plus 2 squared and an x minus 1. This is correct. It's still just not looking like an answer. Gross.
Oh no.
Coop, what do you think?
We're gonna have to figure out the x squared plus 2.
Oh, factor it out? Is that what you're saying?
Yeah.
That they both of these terms, because you guys, this is one term, this is one term. And both of those terms have a factor of x squared plus 2. Not only do they have a factor of x squared plus 2, they have a factor of x squared plus 2 to how much do they both have? Yeah, don't they have it both squared? So let's factor that out. We got an x squared plus 2 to the second power. And how I think it helps you guys to think about is this times what is going to get me that. This times what gets me this. Careful, wait, start with this one, ready? X squared plus 2 squared times what needs to get me x plus 2 cubed? Another x squared plus 2. She's like, oh, this needs to be an x squared plus 2. This times that, again, since the bases match, we would just add my exponents. And we got it. Awesome, right?
Yeah.
Plus, this times what is going to get me all of this? He's like, oh, shoot, we need the 6x and the x minus 1. Oh, my goodness gracious. This still doesn't match. But I'm digging this part. At least this is looking, oh, but I see it over there. Oh, geez, you guys, this is, okay, that's in every problem. Can we simplify this? What's in my parentheses? This is Ms., people. This is Ms. I'm just going to leave this here. We got x squared plus 2 squared.
If you multiply by the 6x,
You're saying distribute that 6x?
yeah,
Okay, so I've got an x squared plus 2, that again I'm just bringing down, plus, what do I get when I distribute that? 6x squared minus 6x. Oh my gosh, you guys. In these parentheses, what's 1x squared plus 6x squared? Holy smokes. Do we have a minus 6x? Do we have a plus 2? Jeez Louise.
You don't keep the parentheses around that when you brought it down, because that wouldn't change.
You mean this part?
No, the left side.
This part?
Yeah.
Oh yeah, we don't have to, and here's why. It was just to the first power. So x squared plus 2 to the first is just the same as x squared plus 2. Good question, Ritz. Whoa.